Can you actually get a plasma cutter for less than 400 bucks that cuts up to 1/2 inch steel? We'll find out in just one moment. I'm Tim Johnson. You're watching Shop Tool Reviews. This is the YesWelder CUT-55DS, and it's a 55 amp DC inverter plasma cutter. Now it actually runs off 110 volts where you can plug it directly into your 110, 120 volt circuit and draw your 15 amps out of, or you can plug it into their adapter here and run it off of 220 volts. Now that running it off of 220 volts is going to give you access to use that full 55 amp output, and that's at 100% duty cycle. Now at 110 volts, you're only at a 60% duty cycle. YesWelder claims that you can cut up to 12 millimeters of penetrating, so in other words, a 1/2 inch thick steel penetrating through the metal. So in other words, kind of starting in the middle and being able to penetrate through, or up to 20 millimeters or 3/4 of an inch of cut through, starting from the edge and being able to cut through it. Now, will it actually do that? We don't know, but let's try it out. So without talking too much more, we'll actually take this over, we'll set it up, very easy setup, and then we'll actually use it and we'll come back and give you our feedback kind of on the first rendition of this. We will have a follow-up part 2 of this as well after we've used it quite a bit and after we've got a good feel for how it does in different types of metal and long-term use as well. So let's get right to setting this up and then we'll come back later and wrap it up. This is the YesWelder CUT-55DS. So in other words, inverter, plasma cutter, 55 amps at 220 volts, but you can also run this on 110, 120 volts as well, which is going to give you, I think, a max of 35 amps. But anyway, it's kind of a self-contained unit as you buy it. So you can buy this kit for, I think it's $3.99. By the way, I believe we'll have even a discount code to where you can actually get a discount on it. And pretty much they have about everything you need to set this thing up. Now we're going to go ahead and just walk through setting this up. If you don't want to watch all this because it may make sense to you, you can jump right to on the screen. We'll show you where to jump to, where we get into the usage of this. But anyway, what you get with the kit is you get a regulator as well as a water filter here. So you get a water trap that's going to trap any fluids, any water in your air compressor lines. So you're definitely going to need an air compressor. You're also going to get some quick connect fittings here with some clear tubing, and basically this is going to connect the regulator to the machine. You're even going to get an Allen wrench for this little Allen head or Allen screw to actually plug up where you could put an air pressure an air pressure gauge. Thank you. Where you can put an air pressure gauge in here. But we don't need that because there's actually one on the front of the machine, and then typically you always have a regulator on your compressor as well. You could put a pressure gauge here, but we're going to take this plug here and plug this up. And then our air comes in here. You see the arrow here flows this way and out to the machine. So we're going to take one of these fittings, put it in here, and then we're going to run this clear line to the machine. You also get a little bracket here that screws right on the back of the machine that holds your regulator as well. By the way, if you already have filtered and dry air in your system, you can go directly in the machine. You don't have to run this. I'm going to kind of use this machine as I lend out, and I want to make sure that any moisture is trapped, which that's a big deal with plasma cutters. You always want to make sure you have dry air. Also that comes with this, was pretty interesting, is some extra tips here, and not just tips, but you get the electrode. You get 3 spare electrodes, so you get one in the machine, and then you get 3 spare electrodes. But you also get the basically between your 110 volt tip and your 220 volt tip, they're different. The orifice on the 220 is a bigger orifice than the 110. Now the interesting part about that is that tells me that the 110 I'll be able to do some finer cutting. So if I'm doing sheet metal work and something like that, I may want to stay on the 110 side because I can use that smaller orifice to do those finer cuts with. So that's interesting. But anyway, basically you get 2 tips of each. The machine comes in the torch already with a 220 volt tip, which by the way, mine looks like it's been used, so maybe they test it from the factory, not sure. And then you get 2 extra cups as well. So you get 3 cups altogether, 1 on the machine or on the torch already, and then 2 extra in the package. You also get a spade terminal here, or a ring terminal, if you will, to clamp onto your red wire on your torch lead. Pretty easy to set all this up, and then you get a DINS connector that's on the earth ground or the ground clamp. So let's go ahead and walk through actually setting this up. Then we'll actually use this machine, start cutting on it, and so forth. And again, if you want to jump straight to the usage of it, you'll see it here down on the bottom of your screen. Okay, so here's the front side of the YesWelder CUT-55DS. So you can see basically you get your air pressure gauge here. You get your basically your amp rating here, your amp setting, as well your 2T, 4T, and wire mesh cutting, which basically means like perforated metals, things like that. It's going to be a different setting of cutting, which is typically a little harder on consumables than just straight steel cutting. And then you get 2T, 4T, which is just about basically activating your torch. I'll get into that once we start using this. And then pretty simple setup here. So basically you have a red lead here. It's going to connect to the red lead on the torch. And then we take this plug off right here, and that's where our torch will hook to, and then the earth ground here, and the control wire right here. So let's go ahead and get this set up. So on the back side here, this is where we're going to hook up our regulator. So as far as the tools you'll need, we'll need a simple Phillips #2 screwdriver, a 14mm wrench, which that's going to take care of our air fitting. So we're going to need a 1/4" NPT air fitting, male, and then whatever's going to hook to your airline, and then a 17mm, which is going to take care of tightening this here, and then some plumbing tape if you want it sealed up, as well as something to cut that that vinyl or PVC line, whatever that clear line is. So pretty simple tool, should have in the shop, shouldn't be a problem whatsoever. Let's go ahead and take these screws out. These are going to be what hold your pressure regulator. So here's the bracket that holds the pressure regulator. Now when I got this bracket, it actually had a tang on it that bent down, and it's supposed to basically mesh with these little indentions here to hold this from spinning. When you go to increase the pressure or decrease the pressure or turn the bowl off, that would keep it from turning. However, the way the tang was, you would have put this like this, which really puts the bleeding this down here right on the cable. So I wanted to raise it up. So I wanted to flip this over like this. And so I was going to bend that tang down. Well, it broke. So anyway, just wanted to let you know there's typically a tang there that holds this. Ours broke off when trying to modify it. So we're going to take our screws here, put our bracket on. Very simple to do. You can figure that part out. And then again, here's our arrow for air pressure or for air flow. So the air is going to flow in here and out here. We're going to go ahead and put our plug in right here. On this hex screw, on this Allen screw, I'm going to go ahead and put some plumber's tape on there, or some Teflon tape on here. A couple wraps should do it. Put that in there. All right, and then so this is going to sit here like this. So we're going to have our vinyl hose that goes on this side. Now it comes with some self-seal or with some sealer already on those threads, but I noticed when I screw it in, it goes basically bottoms out without anything on it. I don't trust that that's going to seal it, so I'm going to go ahead and put some tape on this one as well. Got some tape on there, and again, this is going to be on my output side. And then on this side, basically I'm going to put my airline inlet here, so I'll go ahead and put some tape on that one as well. Get that nice and snug. Slide this up. A red ring on here. There we go. And then we just need a small section of hose. And by the way, this just pushes in. I'm push it in here. It's locked in. Push it in here. That's locked in, so we're good to go now. If I wanted to shorten that up, I could. I can just push push in that blue ring and pull that hose out. Shorten this up a little bit. Push that in, and now we're good to go. So if you're not aware of how a water separator or a water trap or a air regulator works, basically there's a little spring-loaded detent down here. When this pressurizes, this will push down. There's an O-ring inside there that's going to seal this up. And then any water that comes through is going to get trapped here in this bowl. And to release that water, you can just basically push up, or when you turn the machine off and unhook the hose, it's going to automatically jump up and actually bleed any of that water out of there. So that's a water trap, trying to get any moisture out of the system. Again, you don't want moisture going through your plasma, or does not like that. And then basically you can push down to lock this in place, pull it up and turn it righty-tighty or clockwise, and that's going to increase air pressure, and turn it counterclockwise or lefty-loosey, and that's going to decrease air pressure. And again, when you get it dialed in where you want it, push it down, and that's going to lock it into place. Pretty simple there. And then you see here's the on-off switch here on the back of the machine. Now this is also your fan that's going to obviously draw air from inside and cool this machine, or help to keep it cool. So you don't want too much blocking that, but this hose shouldn't hurt anything, and it's kind of going around the outside anyway, so we should be good to go. Now on the front of the machine, hookups are pretty simple. And the only tools we really need for the front side of this are some wire crimpers to crimp on the provided ring terminal onto this red wire here. So put it on there and crimp it down. Make sure it's on there nice and snug. Put the ring terminal on. Put our washer on. And that part's hooked up. Make sure that wire is nice and snug. And we can put our control wire on, which will have a notch. So it only goes one way. It's really almost impossible to get that wrong. And some small fingers to twist that on. And then our big plug here screws in here. This is where our air goes through. It's really our gas. It's just compressed air, but that's our gas in this plasma state that we're creating. So it's just like when you're welding and using argon for your atmosphere or CO2. Same thing here. We're just using air compressed air as our gas. And then here, all we have is this DINS connector for our ground lead or our earth ground, whatever you want to call that. And DINS connector is just going to push in and basically turn half a turn or so, and we're good and locked in. So we're all good and snug here, and that's all as far as setting this machine up. Now we just plug it in, whether we want to plug it in with the included 110 wire, 110, 120, or if you want to plug the adapter in and then run this on 220 volts, we can do that as well. So let's start out. We'll run some different things on 110 or 120, see how well it works, and then we'll come back and increase the voltage input. Okay, let's turn the machine on here and take a look at a couple of things. So number one, we do not have our air compressor hooked up, and so we're getting a nice flashing light right there. But we'll go ahead and look. This is where you can dial in your amp. So you can go down to 10 amps. It says, there we go, now we have 10. And then you can go all the way up to 55 amps. I think that is just kind of an idea, because I know at 120 volts you're not getting 55 amps. So, but regardless, that's your high setting, and this is your low setting. This is going to be your pressure gauge here, and we hook the pressure up. And then this little toggle right here basically is the difference between cutting just standard metal, sheet metal, steel, things like that, just continuous sheet. And this would be your wire mesh setting where you've got kind of perforated metals and things like that where you're wanting to cut, where you're kind of start stopping, or the torch is doing that. This is a better setting to do that in, but we'll just turn it to our regular setting. And then this is your 2T, 4T. And what is 2T, 4T? Well, let me grab the torch here and show you. So in simple terms, 2T and 4T, 2T is 2-touch, and 4T is 4-touch controls. Okay, so 2T, which is kind of your standard, if you will. So 2T controls, 2-touch, is your typical, you're going to pull the trigger to start your cut, release the trigger to stop your cut. So 2-touch controls. 4-touch is either you have a pedal hooked up, and this could be in other machines. So either you have a pedal hooked up, this controlling your on off and maybe even the volume of gas or air or your amp load. Or in this case, you can use the trigger where you pull the trigger to basically activate on, and then you release it and it stays on as you make your cut. So this is if you're in 4T mode. So if I put it in 4T mode, then basically I could pull the trigger to activate it, but then I could let go of that trigger and it would stay activated and stay cutting. And then when I want to stop, I pull the trigger and release. And upon that release, so that 4-touch is actually what's turning that on and turning it off. So that's the difference in 2T and 4T. Typically, when you're just running a trigger, you're going to leave it in 2T. Makes sense. You pull the trigger and it activates, which by the way, we have no air pressure, so that's why it's not activating right now. Release the trigger to deactivate it or to quit cutting. Now, one thing I noticed on the torch here is that it already had a dark spot. I hadn't even used this yet. It's got a dark spot on the torch, so makes me think definitely that this was used. Now, maybe they do that at the factory to make sure it works. And also the cup looks like it had been used a little bit too. Not bad, but just like obviously it's made a cut or two. Now, also there's supposed to be a little ring or a foot that kind of keeps the cutting tip off the metal where you can rest it on the metal, and it's just a wire loop that clips around this. I could not find that in my package. Not a big deal. I've used these things before. I can use it without it. But anyway, it should be in this package as well. It's just a little foot that you can rest the torch down on when you're making your cuts. If we want to change this out, which by the way, I'll go ahead and turn this thing off. I want to change this out to the 110 or 120 tip, which are in this little baggie right here. So this cup unscrews off. This extended tip screws off as well. And this electrode, same way. The electrode's the same whether it's 110 or 220. So I'm going to leave the electrode in there, and I'm going to grab a tip out of the 110 bag here. And as I mentioned, the 110 has got a smaller orifice. So if those fall out of the bag or whatever, you can tell. I think the 220's got a 030 orifice, and I'm not sure what the 110 has. Or maybe the 110 is a 030. Yeah, 110 is an 030 orifice, which is basically the same as your typical MIG wire, to give you an idea of size. And then the 220, that's a larger orifice. I don't know what size that is. But anyway, so I'm going to put this smaller orifice extended tip on. And then I can put my cup on. Again, that's just going to screw on until it seats and give it a little snug, and you should be good to go. So now let's hook up some air pressure, turn this thing on, and we'll get to cutting. Okay, so now all we got to do is turn on our machine. Well, actually, let's plug it in. And by the way, I changed my mind. I was going to start with running it on 110, 120, but I'm going to go ahead and start running it on 220 first, and then back it down to 110. I really think this machine, a plasma cutter, should be run on 220. That's why I'm going to start with that. I'll tell you why later. But anyway, regardless, we're going to start plugging it in. Plug that in a second. We got to hook up our air line. So we'll push that on. And then here's the bleeder that we talked about earlier when we were installing that. You see there's a little bit of a fog mist in there. But you push this up and it drains. But as you unhook it, you see that it's spring loaded and automatically will drain that bowl if there's anything left in there. And then again, the air pressure is going to push that plunger down when I plug it in. All right, so let's plug this in. So we're going to turn on our machine. You see we've got air pressure here. So we've got our pressure gauge here. It's reading right at 80 pounds, 85 pounds, something like that. And then you see we have a button here, which is a 2-touch and the 4-touch, and we're going to go with 2-touch. And we have our, this one I don't understand, it's blinking on, that's supposed to be like metal mesh mode, so cutting like expanded metal, metal mesh, things like that. But you turn that on and it just, all it does is bleed air. So I'm not sure what that setting is. I'm going to leave it on this setting here. Here's your amp dial, so you can dial it all the way up to 55 amps. We're going to start right about 20. We're going to cut some sheet metal, and then we'll step it up to a few others, and we'll dial up the amperage as we go. And we can fine tune that as to what you want to cut. We'll hook our ground lead up here. Just hook it up to our welding table, our fab table, and we should be good to go. Okay, so we got it dialed in to right at 20 amps here. Got air pressure on. Got my ground clamp, my earth clamp grounded to the table, and let's see what we got. Very quick work at 20 amps with that sheet metal there. Let's dial this down, see where we can get to. 15 amps. So I'm going to dial it all the way down to 10 amps at 220. So no problem whatsoever at 10 amps cutting through that sheet metal whatsoever. So I'm going to dial that up a little bit, and we'll cut some 1/8" flat bar, and then we'll keep stepping it up. So I'm going to dial this up to about 15 amps. I'm not sure if that'll cut through this 1/8" flat bar at 15 amps. We'll see. Yeah, no problem whatsoever. So at just 15 amps, we can cut through 1/8. Let me dial this down to 10. I really don't think it's going to penetrate well. I was wrong. So even at 10 amps, we can cut 1/8" flat bar. That's with the 110 volt tip running 220 volts. And as I mentioned, the reason I do that is I get a lot finer tip, a lot finer cut, and should have less slag on this. So you can see on that cut, I do have a little slag on the back side. That could easily be taken off with a grinder. Nice clean cut through here. There's a little bit of dress up that needs to be done, but just really easy penetration. Let me dial that up, and let's just see if the slag is any different on that. You get a good cut. No, it's still about the same. Still get about the same amount of slag on the backside from the cut, even with the amp turned up double. I may be able to back off of air pressure or something like that, but still, that's a pretty clean cut there. But you can continue to dial with, continue to tune with your air pressure and your amperage to get different cuts for the material that you're cutting. So I'm going to go up to 30 amps. I'm going to cut some 3/16 here. So now we got some 3/16 inch angle iron. Quick cleanup with a grinder. You get a nice clean cut there. If I had some type of straight edge or any kind of contour I was following, I could easily make that a lot nicer. So that's penetrating very well, and that's at 30 amps. Let's continue with 30 amps on this 1/4 inch. So this is 1/4 inch plate. I think that's probably that's probably 6 inch. Yeah, that's probably 6 inch, 1/4 inch plate. So let's see what we get here. Okay, you see I'm getting a lot of feedback, so I'm going to turn up my amperage. I'm also going to turn up my air pressure. I'm going to go to 40 amps. I'm also going to bump up to 90 psi, and now let's see what we get here. Go up to 45 amps. Got pretty good penetration, but did have a couple of spots where we didn't get all the way through. I'm going to dress up this metal so it's not hanging on that rust. Now that I've got a cleaner surface to drag across, let's see what we get. Okay, there we go. Cut a little bit slower, dialed up the amperage, a little bit of slag there, not bad. Gonna go back now. So now I've got the 220 volt tip on here, this broader orifice, and let's see if it cuts any better with less slag. Really doesn't like it down there at 40 amps. Let me dial that up to 45. I will say it might cut thicker metals, but at this 1/4 inch plate at 55 amps on 220 volts, I won't say it's struggling to get through, but you're having to move pretty slow to do it. I definitely wouldn't be using it on much thicker than this unless you just had to in a situation like that. But as far as sheet metals, 1/8 inch metal, things like that, this is going to be a great tool for that. So anyway, let's wrap this up. Okay, so here's our first thoughts after using the YesWelder 55DS. It's a very nifty tool, especially for less than $400 for you to be able to get into a plasma cutter, to be able to cut metal, to have just kind of another tool in your arsenal, if you will, if you haven't had a plasma cutter. That's a great deal on that. Now, we've got other machines that probably cut better, perform better, but again, they're multiple times this cost. You know, we're talking $2,000, $2,500, $3,000 for some plasma cutters, and that's just kind of starting that scale. So there's a big difference there, and we don't expect this machine to be able to do everything it will. Now, what we recognized is we really like running at 220 volts, and we really thought of that out of the box. It's just going to perform better at 220. Also, it doesn't seem to be smart in the fact of really knowing when it's plugged into 110 or 220. because you can still dial it up to the full 55 amps, even plugged into 110, where we know we're not getting the cutting power, and you will trip your breakers as well. As we proved, cutting it 25 amps, 30 amps, 40 amps, with it plugged into 110. It's not giving it kind of a range when you're plugged in to know where to go to when it's plugged into 110 versus 220. So just look out for that. But again, I would recommend, if you could wire up a 220 plug, please do so, and you're going to get better performance out of it. If you're just running 110 and you're just cutting sheet metal, you're just cutting, maybe 1/8 inch stuff, you're going to be happy with that as well. It does very well in those thinner metals, even at 110 volts. So make sure you got enough air pressure. Make sure your air is clean. Plasma cutters across the board like clean, dry air. If you're not feeding it clean, dry air, you are going to go through consumables and you are going to have issues. You do not want water droplets going through this system or any other plasma system. So make sure your air is clean. Make sure you're utilizing that, that regulator and that water trap that they provide for you, or at least have one in your system. We did notice when we set this up, we had an air leak in the back. Basically, we pulled out the fitting, put some Teflon tape around it, and it was one that was already installed when the machine got here, and put that back in and eliminated that air leak. Instructions are not great. Really doesn't give you a lot of specifics on how to set this up. I did mention in the while I was cutting, the continuous mode versus the wire mesh mode. And in the continuous mode, it works, but it's just continually going to feed air, so it's always going to be purging air through the system. Where the metal mesh mode is going to, the air is going to activate when you pull the trigger, and then it's going to have a 20-second post flow after you let go of that trigger. So that does work. And I showed a little bit on the 2-touch, 4-touch. I really didn't do any 4-touch, but I talked about that. But for the price, for $399, it's really hard to beat. Again, if you're doing thicker metals, it may not be the machine for you. If you're continually doing stuff that is, greater than 1/4 inch, you may want to look into other things. Now, if you're just every once in a while doing that, it'll be fine for you. But again, if you're sticking around, light duty fab, you're working on cars and trucks and things like that, sheet metal, or you're fabbing up things that are, 1/8 inch, 3/16, 20 gauge, 10 gauge, things like that, this is going to be a great plasma cutter for you. Longevity wise, not sure yet. Again, we'll do a follow-up to this as well. Setting it up very easy. It's kind of all self-contained as well. So our thoughts are, for the price, a great entry-level plasma cutter, which I think that's what they're after anyway. I don't think they're after that long-term pro, that huge fabrication shop. They're after that person that's maybe never had a plasma cutter, and by all means, it's going to fit in their budget. Hey, make sure you check it out. Again, it's the YesWelder 55DS. We got a discount code for you in the description. They asked us if we wanted to, make a commission or pass that discount on. And said, by all means, let's pass that discount on to you guys. Could care less about making a commission on this whatsoever. So check it out. Again, that link should be a discounted code. And check it out from YesWelder. They've got some other pretty cool products as well. Have a great day. Keep smiling.